Okay. Hello everyone. My name is Muhammad Fatur Rahman with ID student 123490053 from Instrumentation and Automation Engineering Institute Technology Sumatera. In this video, I will be explaining the concept of timer in PLC or programmable logic controller. Uh, Timers are one of the most essential components in automation system. Uh, Timer helping control the timing of process, ensuring that things happen in the right order and with the concert delay. Whether you're controlling machine, actuator, or processing PLC, timer play a critical role in making sure everything works efficiently. A timer in PLC is an internal instruction used to create delay or control how long an output remains active or inactive based on specific input coordinate. Uh, think of think of it like a digital stopwatch that starts when the condition is made the count until the percent time has passed. Uh, okay, timer in PLC serve two main functions. One, delay activation. The timer allows you to introduce a delay before an action occurs. For example, you may want a machine to wait for a few seconds before starting to operate. Two, delay uh, the activation. Timer can also ensure that an output remains active for a certain time after an input condition is removed. This prevents sudden change and ensures process complete properly. Timers are used as essentially is system like controlling pneumatic actuator, managing lighting system, and regulating heating, ventilation, and air conditioning system. There are two primary types of timer in PLC system: timer on delay or TON and timer of delay or TOS. Uh, Both uh, timers have different application depending on the system requirement. First, TON or uh, timer on delay. The TON timer starts counting when the input condition becomes true. After the present time has passed, the output is active. It, it is commonly used when there is a need to delay an action after an input condition becomes true. Example of TON or timer on delay in pneumatic system when controlling a cylinder, you might want to wait for a few seconds before the cylinder extends after a sensor is active. The tone timer delay the extension until the preset time pass. Second, to TOF or timer of delay. In contrast, the TOF timer start counting when the input condition turns off. The output remains active while the input is true, but once the input becomes false, the timer will count down before turning off the output. Example, imagine a system where a light remains on for a few seconds after a switch is turned off. The timer keeps the light on till the set time after the switch is turned off, providing a smooth transition rather than an immediate shutdown. Okay. Uh, in a PLC, timer work by counting the time elapsed since a condition is met. They have two main components. First, preset time or PT. This is the time the timer is set to and it determines how long the timer will count before triggering an action. Accumulate time or AT. This is the actual time the timer has counted. Once the accumulated time equals the preset time, the output will change according to the program logic. For example, if a preset time is set to 5 seconds, the timer will start when the input condition is met. After 5 seconds, the output will either active or deactive, depending on their timer configuration. Okay, this is we has we have leader PLC. For we are copy this program with JX1 software. Click JX1 programmer. The first we click this file, new, type, click OK. Uh, the first program we use the new contact 000 on, and with new close contact 001, the command is off, like this. And we have add a horizontal, new horizontal, and new coil W W000 system. Okay, then down, click new contact W000 system and new vertical line like this. Uh, Next, we add the new contact, the click W000 system and new close contact T0001 and comment timer like this. Next, add the horizontal line and new coil. Oh, sorry. This new PLC instruction. Click write theme space 0000 space 5T to comments timer on. Next, in row 2, we add the new contact W000 system 002 PB and new horizontal line and new coil W000001. Okay, like this. And W001 and you add new contact time 0000 timer on. Add like this. New instruction team 0001 15 like this. Uh, Next, we add a new contact W000 system to 0000 timer on to 0001. Add new horizontal line, new coil Q, no, 100 solenoid like this. Okay, ladder logic is the graphical programming language used to design PLC program. It represents control process as a set of rules. It's representing different operational. In ladder logic, timers are placed in the round to control time delay. Here, how timers are represented in logic. First one, TON, timer example. Yeah. First, we have start button TON T1. In example, when the start button is pressed, the tone timer will start counting for 5 seconds. Okay, once the 5 seconds are up, the output will be active. Next, TOF timer example. This configuration means that when the stop button is pressed, the TOF timer will start counting. The output will stay active for 5 seconds after the stop button is released. Okay, now the R understand to how timers work. Let's explore some common application in automation system. Okay, first the example we have a machine and process control. Okay, timer are widely used in manufacturing systems to control the timing of operation. For example, in an automation packing machine, timer can control how long the machine should wait before starting the next cycle or how long it should take to complete a specific task. And a second example, we have pneumatic system. Okay. Timer play a crucial role in pneumatic system that control actuator like cylinder. A common application would be to control the extension and restriction of a pneumatic cylinder with precise timing. Timer ensuring that the cylinder extend the retract with the concert delay between each action, making the system more reliable and efficient. And third, we have like lighting and HVAC system. Okay, timer are also used in system to fa control light, fans, and other equipment. For instance, in lighting system, timer can delay the uh, turn off of light after the room is empty. In HVAC system, timer help manage the operation of fans or air conditioning unit, ensuring they run for a specific time based on the temperature or other condition. Uh, the fourth, we have a sequential operation. Okay, timers are especially useful when managing multiple machines or processes that must operate in a specific sequence. For example, in conveyor system, a timer might be used to delay the start of machine or process until the previous one has completed its cycle, preventing overlap and ensuring smooth transition. Okay, we have how timer help improve efficiency and reliability. Timers are essentially for making ensure automation system run smoothly and efficiently. They ensure that processes are timed correctly, preventing overlap or mistake. By automating timing function, timer reduce the need for manual intervention, which reduce the risk of human error and increase system reliability. In addition to making process more efficient, timer also help improve safety. They prevent machine or process from turning on or off abruptly, which could potentially damage equipment or create use. unsafe conditions. Timer provide a smooth transition and ensure that each component operates as intended within the system. Okay, conclusion, the important time in automation. By understanding how to implementation timer in leader logic, you can design more efficient and reliable system. Timer allows for precise control over when actions are triggered. For them indispensable in modern automation, with a solid understanding of timer and their application, you'll be able to optimize processing, increase efficiently, and reduce the chance of error in system, automatic system. Okay, thank you for watching. I hope this video has helped you understand the critical role timers play in PLC system. If you have any question, feel free to leave them in the comment, and I'll happy to answer them. Okay, thank you for watching and goodbye.